It's great to be here. My name is Nick, and this morning I want to bring you along my company's insight into a growing challenge that we see in the area of Open RAN architecture and how Open RAN architecture interoperates with non-Open RAN architecture. This is effectively related to the challenge of how all this relates to network assurance. In WIM Technologies, we focus a lot on RAN automation across multiple architectures, and I hope this brings some interesting insight in your areas of work. Okay, I've chosen a few recent quotes and commitments from government organizations and operators on plans for Open RAN. So a lot of we see this a lot coming now, and actually will come along the next year. The Department for Culture, Media and Sports has an ambition of 35% of the UK's mobile network traffic to be carried over Open RAN by 2030. And Vodafone Group is also expecting around the same, about 30% of the infrastructure masts across Europe to be Open RAN. The other operators are also thinking along the same line, and we can expect that by 2030, indeed, around 30%, maybe less for some operators, maybe more for others, will be on Open RAN architecture. What does that mean for the remaining 70%? Well, the 70% will remain proprietary RAN. And this means that for the next 10 years and beyond, really, the mobile operators will have what we call a hybrid RAN, a mixture between proprietary, or also some competitors call this closed RAN, and Open RAN. Now, this inevitably means an increased complexity, increased architectural complexity, increased operational cost of managing that complexity. But all these particularly affect new challenges to managing a one network RAN quality, assuring the RAN quality. And I'll go further into what that means in practice. What is a typical hybrid RAN? What can we expect from architectural perspective for the networks in the upcoming 10 years? So we can have this is just an example where an operator will can have two types of proprietary RAN vendors and an Open RAN architecture could be a mixture. It could be 3 proprietary RAN vendors, could be 1 proprietary vendors, and within the Open RAN architecture, there's also could be segregation by having more than one Open RAN type of software, which from the perspective of network quality assurance means further segregation in terms of managing the radio configuration. This picture suggests that that architecture is sort of somewhat split. And indeed, the moment operators that have more than one RAN vendor usually prefer to split the infrastructure on geographical levels in order to effectively minimize the challenge of assuring interoperability and optimization that goes across those two vendors. That might be the case also for Open RAN, and we do see that with those operators that have started to deploy Open RAN, which, for example, in the case of Vodafone, they are using it to replace other vendors. But a lot of the indications from the industry is that operators will be deploying Open RAN in the case of small cells, in the case of 5G capacity increase. So we can expect that Open RAN architecture will sit alongside proprietary RAN architecture from a geographical perspective. and the interaction between the two architectures will be much closer. So it may not be actually possible to have this geographical segregation. And this brings a challenge to network quality. So to examine, for example, a typical scenario where a mobile operator has two types of proprietary RAN vendors. So this challenge already exists with the need to actually assure the same user experience across both types of architecture. So we want a user who, let's say we have a vendor A, could be Ericsson, could be Huawei, could be Nokia, and the vendor B. We want the users that roam on those and use that architecture to have the same experience. That means the configuration of those vendors needs to be consistent. And that's where the problem usually is, because the RAN vendors are different and they have different types of parameters, different types of options, and even for those settings that are the same, because of course we're talking the same type of technology. 2G is the same everywhere, 4G is the same everywhere, but the different features, and even for the cases where the features are the same, the configuration of those parameters requires different instruction sets. So there's a lot of then effectively complexity, and practically that might require teams to double efforts and effectively segregate the operations and the management of those two networks. Now, Open RAN brings additional challenges. For those operators that are a single vendor at the moment, that will be a first experience of actually handling two types of architectures. For those that already have this, that just brings an additional complexity, because adding Open RAN means another type of set of radio configuration that needs to be considered, which will be different than the proprietary vendors. It means there will be a need for more expertise and knowledge first, and then procedural changes in terms of how that configuration is managed. And the reason I've included here 2G, 4G, 5G is because we do expect these technologies to be remaining in the case of Europe, but in some cases this could actually include 3G as well. So the more radio access technologies exist, also the higher the complexity, because each one of those technologies again has a different type of configuration needs. And the challenges within this difference, as RAN proprietary vendors have different type of parameters and capabilities which need to be managed and configured. So there's Open RAN. I've included here just an indication of the number of different parameters per technology for a selection of vendors, and we have here Samsung, which is an Open RAN vendor at the moment. These numbers can vary depending on the radio products, and half of those parameters can be expected that need to be managed in terms of optimization, in terms of configuration. But what I would like to focus on is the difference. We see a huge difference between options and parameters on different vendors, and we do expect that to be also on Open RAN software. So that means that a lot of consideration needs to be taken in terms of how actually things need to be configured in order for the end user experience to be similar or the same. How does this relate practically to network quality? The reason actually a lot of parameters and configuration options is on the RAN, to maybe compared to other parts of the mobile network, such as the core or the transport, is because of the nature of the radio access channel. There's lots of chances of things that can fail because the radio channel is random, and the parameters that need to be configured govern a lot of different types of use cases that impact how we operate the network and the user experience. So some of the most basic ones that need to be covered, that engineers would need to look at, and systems need to assure from the perspective of network quality are things like transmission power control, modulation and coding, handover and mobility parameters, load balancing, cell reselection. All these relate in different ways to aspects of, for example, signal strength, data speeds, network quality, drop calls, capacity management, etc. And as I've pointed out in the previous sections, you can expect those are different. They're already different for, let's say, for networks that have more than one run vendor. For Open RAN, again, adds further complexity. Addressing those from a practical perspective means that operators need to have different teams that understand how, for example, to set up load balancing in the best way for one type of architecture or for one vendor, and do the same for the other. So that's first in terms of knowledge. The second is the implementation of this, where once the radio design has been chosen, or how actually the parameters need to be configured is decided on, then this needs to be implemented and assured. And for Open RAN, we have all these wonderful new features and open interfaces. So this is from the Open RAN Alliance, the standard architecture that we expect to have for Open RAN, with open interfaces such as the A1 and O1, a near real-time rig, non-real-time rig, responsible for intelligent optimization, service management and orchestration framework, responsible for aspects related to baseline policy management and overall radio design. So from specifically talking about the Open RAN architecture, we have a lot of possibilities for minimizing the need for human interaction or manual labor related to the implementation of the radio configuration, the implementation of the parameter settings. If we have more than one Open RAN software, again, this architecture helps really to govern this. So with one RAN intelligence controller, the intelligent optimization can be carried out and implemented. What does that mean if we have then a hybrid RAN? Well, we have another box, which is a closed system. The similar aspects exist for proprietary architecture in terms of intelligence optimization, which is carried out by a SOM module, or service management orchestration, again covered by different elements and different type of solutions for configuration management. Those are usually something that the RAN vendors themselves provide. And they're part of the set, the tool set. But how they work inside, well, again, it's proprietary. There's no open interfaces, and although there are interfaces that allow for external third-party systems to connect to those are very specific for each RAN vendor. So we effectively have a wall that can exist in a practical deployment for a hybrid RAN network. And the challenge is how this should be managed effectively. How the implementation of the radio configuration can be handled, how the assurance can be handled, or practical things, for example, mobility between a cell that is on the Open RAN architecture and a cell that's on proprietary architecture is ubiquitous and streamlined. And the first straightforward way to address this is by having larger teams deploying a lot of engineers to do this manually. And indeed, that's what probably a lot of operators are going to start to do. But soon, it will come to the problem that this becomes very difficult to do, and costly, effectively. And the answer is really going into automation, going into solutions that can actually carry optimization, carry out configuration, and run quality assurance across the different types of architectures. So, as mentioned, the proprietary run has solutions for configuration management and so on within each vendor, and there are solutions there that sit on top and provide this. And the different run vendors provide certain interfaces. Just some examples of APIs or other interfaces which allow for configuration management and intelligent optimization to be handled externally. The Open Run has a RIC and service management orchestration engine. How do we bring these together? Through effectively hybrid run configuration management orchestration. Unfortunately, at the moment, the market is, and the industry is quite focused on the Open Run specifically. There's a lot of talk about the Run Intelligence Controller and the benefits and amazing things that we can do with it, which is all great. But if we have 70% of the network being proprietary run, then this will not really make too much of a difference for the end users of a mobile network. And what we need to look into as an industry is actually how to bridge those gaps. And more solutions need to come on the market to address this problem. From our experience, there are very, very few solutions out there at the moment that effectively address this. And we believe that there should be more talk and more solutions come out of this to address this problem. This challenge is already a reality. It's already a reality for those operators that are deploying Open Run in practice, which has started and will increase exponentially. So this, we believe, from the technologies, this challenge should be addressed now and looked in as more of a priority compared to, for example, deployment of a RIC for Open Run vendor, or specifically just focus on an Open Run architecture from a practical perspective for any operator that looks to embark on the journey for Open Run. Thank you. So I hope that was insightful, and I welcome your questions.
Thanks very much, Nick. And I think you also get an extra well done for carrying on, not missing a beat in our minor prop malfunction as you were speaking. So are there any questions for Nick? Okay. I can use my mic.
Thank you. Francis Haysom, Appledore Research. Really like the presentation, and we certainly agree with the idea that orchestration is a key part of any multi-vendor, multi-domain problem. I really had a question, which was how understand that Open RAN is coming, but how is this different than the problem that already exists with multi-vendor networks? It seems to be characterizing Open RAN as something that is distinctly difficult, rather than it's the same problem, just in a slightly different packaging.
That's a good question. So it practically does feel it's the same, because, as I said, from a certain angle, adding an Open RAN architecture, Open RAN vendor is like adding another proprietary vendor. You have another set of parameters. The challenge, the difference is that it requires a different level of architecture, and from a systems orchestration perspective, it requires a different type of solutions to manage similar functions. To give you an example, if an operator already has more than one proprietary vendor, they might have bought a third-party solution for a centralized SOM to do intelligent optimization, and that bridges a lot of practical aspects of cross-architecture optimization. When they bring Open RAN, that centralized SON needs to, well, may not actually work on the RAN, because on the RAN now the SON function is taken by a RIC. So the operator then would say, okay, we need to buy a RIC in order to perform this intelligence optimization, and they should, because the RIC provides a different level, a much better level of optimization in the case of near real time that you can't do with a SON. So then this creates, naturally can create a much more segregated structure. So the operators can no longer say, oh, my existing SON solution will cover Open RAN. It won't. Or the RIC that I buy will cover proprietary RAN. It won't. At least out marketing. So this is the specific challenge when it comes to Open RAN that is a bit more specific, more I'll say more elevated than what we have with just bringing another proprietary RAN vendor.
So in essence, you're seeing this is the solution when you start to implement the RIC. If you're just opening up the frontal, as it were, which is what a lot of the sort of published Open RAN at the moment, it would still very much be a kind of SON-like structure. It would be like having another vendor in the network.
Yes, yeah.
Okay, are there any other questions for Nick? Right, I just had one. I mean, I'm just curious to, what is your sense in talking to operators that they're addressing this or thinking it's on their radar now?
At the moment, I don't think it is. There is it's a bit of a slow movement to actually understanding this is a challenge. At the moment, the operators are looking a lot more into the burning questions about Open RAN architecture, like choosing the different types of suppliers and how actually the whole architecture mix will look, since they need to choose the vendor for the RAN software, for the hardware, for the O-Cloud, and so on. So the burning pressing needs are really to make that right, and only second comes to the actual network quality, and that stems from the fact that usually operators have completely different structures and teams for the people that are responsible for the systems architecture, hardware architecture, and those that are responsible for operating the radio network and quality. So what I see in my daily work with those operators that engage with working with Open RAN is that they are yet to realize this is a challenge, and it's going to be more of a challenge that comes as a reactive. Now we have deployed this. Users are complaining that we have problems. Radio configuration team, why can't you assure this? And they say, well, we don't have the systems for this. We don't have the people. This is too complicated.
Interesting. Okay, something more in the management and orchestration to be aware of and to be thinking about then with Open RAN. So, okay, I think we'll leave it there. Nick, thanks very much.
Thank you.